So in the last video we finished off setting up the VPC side of things in the topology. So we've got VPC domain 100, 200 and 300 all set up, and then we've got the VPCs down to the servers also set up. So in this video we're going to start looking at the overlay, or sorry, the underlay and the overlay setup, including the PIM multicast setup and also adding of the L2 VNIs. So what we'll do first is we'll just verify that everything looks good from a VPC perspective. So we'll just do a show VPC brief on all the leaves, just make sure that everything looks good. It does so far. Yeah, everything there looks good. So first thing we need to do globally is we need to enable a load of features. So we'll get everyone into global configuration mode and we'll enable features for OSPF. We'll enable BGP for PIM, fabric, forwarding, interface, Vlan. This is going to all the devices, by the way. And then VN segment based, also Vlan based, and NVE overlay. So that should have enabled that on all the switches, which it looks like it has. And then the next thing to do is create the loopback. So we will have loopback 0, which is going to be essentially the router ID loopback, which will terminate the BGP and the OSPF sessions. So we'll create that on all the devices. So interface loopback 0. We'll globally no shot that, and then on each device we'll give it an IP address. So we'll start with .1 and we'll work our way to the right. So .2, .3, .4, 5, 6, 7, and 8. And then we can configure OSPF. I can do that globally actually under here, so I can do router OSPF underlay, and we'll log adjacency changes. And then if we come back into interface loopback 0, we can say IP router OSPF underlay area, and then we'll use the backbone area. So that's done that everywhere, so we should have loopback 0 enabled and also in OSPF. So now configuring the physical interfaces. So from the spine perspective we've got 6 interfaces going down to the leaves, and the leaves have got 2 interfaces going up to the spines. So we'll do the spine interfaces first. So come out of that interface ETH1/1 to 6 as a range. We'll no shut them. We'll say that they're not switch ports. We'll set the MTU to jumbo frames at 9216. Set medium P2P, and then we'll set IP unnumbered from loopback 0, just so we don't have to put physical IPs on these interfaces. And then we'll say IP router OSPF underlay. We'll add this to the backbone area as well. And we essentially, if I grab ETH11, just copy that configuration on the other spine, we should be able to do to 6, and it's pretty much the same configuration. So it's not a switch port, we're setting the MTU to jumbo frames, we're setting medium P2P, the unnumbered, adding it to OSPF, and then no shutting the interface or interfaces because there's 6 of them. So that's all those done. We should see that if we do a show interface status, they all show as routed, which is good. Same on spine 2. They should all show as routed. Good. So from a leaf perspective, the config is pretty much exactly the same. but it's just different interfaces. So ETH1/1 to 2, and as long as if I grab this configuration from here, I can just put this on all of the leaves. So if I copy that and change this so it's int ETH1/1 to 2, then we can essentially just copy that onto all of the leaves and it'll configure those interfaces for us. Perfect. So again, if we do a show, in fact we'll do globally show interface status, we can see that we've got 2 routed ports there, 2 routed ports there. Oh, looks like it didn't finish that off. Show int status, 2 routed ports there, same thing. Two routed ports there, and we can safely assume that, yeah, 2 routed ports there and 2 routed ports there. So we should hopefully have some OSPF neighborships. So show IP OSPF underlay neighbors. We can see that we have got neighborships with 3, 4, 5, 6, 7, and 8, which are all the other, essentially all the leaves, which is a good sign. Same thing, 3, 4, 5, 6, 7, 8. And then if we do a show IP route OSPF underlay, we should see we've got a lot of routes in there. We should be able to, for example, ping to leaf 8, not leaf 8, IP8, which will be leaf 6. We should have connectivity all the way down there, which we do. And then we should also have connectivity between the 2 spines. Which we do. Took a second, but we do. So, now that we've got IP connectivity, we can start with the multicast setup. So, we're going to use Anycast RP on the 2 spines. So they're going to essentially have an address that's on both, which will be 10.0.0.99. And that will be used by the leaves to send multicast bound traffic to the RP4. So what we'll do is on both spines we will say IP PIM, we'll set the RP address to 10.0.0.99, and we'll say the group list is 224.0.0.0.4, and then we'll set the IP PIM source specific multicast range to 232.0.0.0.0/8, and then now we can say IP PIM Anycast RP. We'll give it the address of the RP, and then we'll give it the first loopback and then the second loopback. So what we're essentially saying is that spine 1 and spine 2 are this Anycast RP. We then need to configure that address. So interface loopback 1, IP address 10.0.0.99/32 mask. We also want to put this into OSPF. In the backbone area, and then because we're now doing multicast, we need to say IP PIM sparse mode. We also need to come into loopback 0 and say PIM sparse mode as well, and ETH1/1 to 6. So all the interfaces going down to the leaves also need to be configured as PIM sparse mode. So let's show run section PIM. So we'll copy that because it's the exact same configuration on spine 2. and then we'll configure int loopback 1 IP address is 10.0.0.99, which is the same as spine 1. We'll set IP router OSPF underlay area 00, and we've got to make sure actually IP PIM we no shut that, because some Nexus devices do, some Nexus devices don't automatically. No shut, just to make sure. So then let's also just configure IP PIM sparse mode on loopback 1, and then 1 to 6 our underlay IP addresses with PIM sparse mode as well. So essentially we've configured the RP, the loopback for the RP, and then the we've added sparse mode to pretty much all the interfaces that we've got configured. So from a spine perspective, that is pretty much it for the configuration. If we do a show IP PIM RP, we should see that everything there looks good. We can see there's an asterisk next to us because we're .1 here, and we can see we've got some uptime counting there. If we do the same thing on spine 2, we'll see the same thing, but we've got an asterisk next to 2 because we are .2, we're spine 2, and everything looks good from there. So we do need to show, well, tell the leaves about the RP, and also do the sparse mode configuration. So on all the leaves, the configuration is exactly the same. It's IP PIM RP address, and then the address of the RP, which is .99, and then we've got to set the group list, which is 224.0.0.0/4, and then the IP PIM SSM range, which is source specific multicast. We'll set that to 232.0.0.0/8. And then last thing, interface loopback 0, IP PIM sparse mode, and IP PIM sparse mode on the physical interfaces that go up to the spines. So show run section PIM, we'll take that and we'll whack that on all the leaves, because it's exactly the same configuration everywhere. And then int loop 0 IP PIM sparse mode, and just do this on all the devices. Int with an N. And then on leaf 5, and last but not least, leaf 6. Perfect. We can do a similar command on the leaves. If we do show IP PIM RP, we can see that that's essentially what we're configured with. So we're configured with that as an RP, and then this is the group range that's going to use that rendezvous point essentially. So now that that's all done, we can start on the NVE configuration. So that's the network virtual endpoint. That's the essentially the VTEP on all the leaves. So as Cisco best practice, it's best practice to have a separate loopback for the VTEP. So what we're going to do is we're going to configure loopback 1. So loopback 1, and then we're going to give this IP address of 10.0.1.1/32, and we're going to essentially iterate that last octet across all the leaves. So I'll just grab that. We'll do 1, that's 2, that's 3, 4, 5, and 6. That tab moved, that's odd. We do need to know shut that on all the leaves. Perfect. So this is where the first sort of specific VPC configuration comes into play. So normally in a VXLAN fabric you would give every VTEP its own IP address, and that would be it. You'd just configure that, and then that would be used on the NVE interface. But what we have to do when we're using VPC is we have to configure a secondary IP address on the loopback, which is shared between the VPC members. So essentially, when the routing updates go out to the spines, to the root reflectors, they will, instead of having the specific IP address of that leaf, they will have the secondary IP address, which is the shared IP address between the two leaves, so that any other VTEPs that are going to be forwarding traffic to that VPC domain see the shared address, not the specific address of the one leaf. So it's sort of it's almost like an Anycast. Well, it's called Anycast VTEP. That's the kind of name for it that Cisco use. So essentially, the traffic will land on either of the two VPC VTEPs rather than specifically going to one. So it allows for a bit of low balancing, a bit of high availability. So what we do need to do first is we need to say IP router OSPF underlay area, and then set the backbone area so that these are in OSPF as well. We'll do that on everyone. We do also need to say IP PIM sparse mode on the loopback as well. And then, right, let's configure these IP addresses then. So IP address, so what we're going to do is we're going to use 1.101 secondary. So we'll use 101 on leaf 1 and 2. Leaf 3 and 4, we'll use 102. And then leaf 5 and 6, we'll use 103. Like so. We'll just come out of that. If we have a look at the routing table on the spines, so if we do a show IP route, we should see down here now that we've got 101, 102, 103, and we can see that that's essentially equal cost multipathed to for 101 leaf 1 and 2, for 102 leaf 3 and 4, and 103 leaf 5 and 6. So that is a good sign. Everything there looks to be working. So now we'll configure the NVE interface itself. So again, only for the leaves interface NVE 1, we will no shut it. We'll set the host reachability protocol to BGP, and we'll set the source interface to loopback 1. The next VPC specific configuration here is that we want to advertise the virtual RMAC, and it'll give you this warning to say that you also need to configure advertise PIP under BGP, which we will do as well. But this essentially creates a virtual MAC address, which again is a bit like the this address we've configured here. It's shared between the two VPC peers, so that instead of on the routing updates it having the NVE MAC address of one of the leaves, it's got a shared MAC address of both of the leaves. We can see that, I believe there's a show NVE interface NVE 1, so that shows us the local router MAC, and I believe there's a detail version of this, yeah, there we go, that's got the virtual router MAC. So we can see that this is the physical, well, it's not the physical, but it's the local MAC address, and then this is this virtual MAC address. So what we'd expect to see in the routing updates, now that we've got this enabled, is that we'd see this MAC address rather than this MAC address. They'll still both function, but we should just see this go out, so that things can, so that traffic can come back in, and it's not tied to a specific VTEP. So let's take this configuration and put it on all the leaves, because it's the exact same configuration for everyone. If, for example, we did this command on leaf 2, we should see there, so 0200, 0200, 0200, 0A00, 0A00, and then we've got 0165, and this is 0165, so that is a shared MAC address between those two, and then these should be different. So we've got 5003, 1B08, and we can see that's already different. It's the same other part of the MAC address, but we've just got a difference with the number there. So that's how that works. So we should have that on all the leaves, which we do. Perfect. We should also see that interface is up. So if we do show interface NVE 1, we can see it's up and its admin state is up. That's a good sign as well. So that is effectively the underlay kind of set up. So now what we can look at is the BGP configuration, which is the kind of overlay where the L2 VPN EVPN address family comes in, and we start to exchange routes across the fabric. So let's just check everyone's. In fact, I can get everyone back to configuration mode, and then we just need to enable something globally everywhere, which is NVE Overlay EVPN. Enable that everywhere, and we'll start with BGP on the spines. So router BGP will use the autonomous system of 64500. We'll log neighbor changes, because why not? We'll come into the address family of IPv4 unicast to remove that. Address family L2 VPN EVPN. And we'll say we want to retain root target all. Exit. And then, right, so because there's so many peerings, what we'll do is we'll create a template, a peering template. So template peer leaf, and we'll say remote AS. These are all iBGP neighborships, so we'll use the same autonomous system. We'll set the update source as loopback 0, because we designated that as our router ID loopback. So address family of IPv4 unicast. We'll send community extended, and we'll say we are a root reflector, or we'll say these are root reflector clients. So the spines are going to be acting as root reflectors, so that we don't need a full mesh of peerings between all the leaves. We'll also allow soft reconfiguration inbound. We'll come out of that and come into the address family of L2 VPN EVPN. We'll send community, we'll do both, and we'll also say root reflector client. So now if we say neighbor 10.0.0.3, which is leaf 1.3, we'll say inherit peer, and then we'll say leaf. So that's going to essentially configure that as a neighbor, and it's going to use all of the configuration that we put in that peer template. So we'll do .4 as well, .5, .6, .7, and .8. So that's all the leaves. So let's have a look at that in its entirety. So this is the configuration that's essentially on all the leaves. So the iBGP neighborships, we're using loopback 0. We've got two address families. In both, we're sending extended communities. We are configuring the leaves as root reflector clients, and we're also allowing soft reconfiguration inbound if we need it. So we'll grab that configuration, because it is exactly the same on spine 2, like so, and let that run through. Cool. And then the leaves I've got a bit less configuration, but it's pretty much the same. So router BGP 64500. We will log neighborship changes. Address family of IPv4 unicast will enable, and then the address family of L2 VPN EVPN will also enable. And then this is again where there's a specific, so where up here it says warning, advertised PIP under BGP must also be configured for proper operation. This is where we essentially say advertise, and we've got advertised PIP here. So that's what we want to add there, and that's under the address family of L2 VPN EVPN. So we'll do that. We'll also, because there's going to be two peerings, we may as well create a template. So template peer, we'll call this spine. Again, we are IBGP, so we will configure remote AS as 64500. Set the update source as loopback 0. Address family of IPv4 unicast. We will send community both, and then we'll just do soft reconfiguration inbound. Address family L2 VPN EVPN, and then we'll just do send community both. Our two peers, or two neighbours should I say, will be neighbour 10.0.0.1 inherit peer spine, and .2 with the same. So again, for completeness sake, we'll have a look at the full configuration. So we've created a peer for a peer template for the spine with IBGP. We're using loopback 0 as our update source. We've got two address families, and all we're really doing is saying that we're going to send extended communities, and then we've got our two peers, which are the spines. This configuration is exactly the same on all the other leaves, so we will copy and paste that everywhere, and hopefully once this is in, we should have some peerings. So wait for that to run through. That all looks good. So on the spines, if we do a show BGP L2 VPN EVPN summary, let me just make that look a bit better. In fact, let me do this across the board. There we go. So we can see that we've got a active neighbourship to everyone. We're not seeing any prefixes yet because we haven't really done anything to advertise any prefixes. Missed the S again. There we go. Perfect. So that looks like we've got full pairings up between all of our devices. So that is effectively the overlay setup. So now we can just start creating the L2 VNIs or the VLANs essentially on the leaves. So we have got devices in VLAN 10 and VLAN 20. So what we'll do is come into configuration mode. Again, this is just the leaf configuration. So VLAN 10, set the VN segment to 1010. We'll come into interface NVE 1. We'll set the member VNI to 1010. We will enable ARP suppression because it's a good idea. As long as you haven't got loads and loads of silent hosts. We'll set the multicast group to 224.1.1.192, which is within our multicast group that we set up on the rendezvous points. And then we'll come into here, say EVPN for the VNI of 1010, say it's layer 2, set the RD to auto, set the root target for both to auto as well. So show run VLAN. This again is rather repetitive because it's the same configuration on all the leaves, so we'll create VLAN 10. we will show run interface NVE1. And then we'll say section E VPN. Grab that and then just adjust it slightly, like so. What we will also do as well is, because we've got VLAN 20, we can configure this before we've created the VLAN, but if we add 20 there and 20 there, we can use the same multicast group, that's fine. We'll just configure the VNI at least for VLAN 20, and then we can go back through all the leaves and actually configure VLAN 20 itself. So last there, and then we'll come out of here, VLAN 20, VN segment is 1020, and then we'll just whack that across all the leaves as well, and then we should be able to configure our port channels that we weren't able to put a VLAN on before because we didn't have them created. Perfect. So if we do exactly that, so int PO2 switch port access VLAN 10, so port channel 2 on all the switches is the port channel going to the server on VLAN 10, and then port channel 3 is the server going on VLAN 20. So switch port access VLAN 20, if we copy this and edit it, just to make it a bit quicker, getting it onto all of the devices. Perfect. So if we do a show interface status, we can now see that the two interfaces that we've got that are going to the servers essentially are on those specific VLANs. So if we, because we're using ARP suppression, we can look at show IP ARP suppression cache for VLAN 10. You can see we've got nothing in there at the minute. We can have a look for VLAN 20. We can see we've got nothing in there at the minute. If we look on the spines and do a show BGP L2 VPN EVPN, we can see there's nothing there, there's no routes. So if we come on to server 1 VL10, and so this is 10.1.1.1. We've got, if we look at server 3 VL10, see what IP address this has got. This is on 10.1.1.2. So what we should be able to do is ping between these, and we can. Perfect. We'll stop with that, and then we'll just make sure. We should be able to go the other way, but we'll just make sure. We can. Perfect. So now if we have a look on our spines, if we do that again, we'll see that now we've got some routes. We can see 10.1.1, 10.1.1.2 there as well, and then we can also see MAC address routes in there as well. So they're all type 2 EVPN routes, which have either got a MAC address and an IP address, or just a MAC address, and we can see the two types there. So that is just a MAC address, because we can see the IP is all zeros and it's got a MAC address populated, and then this is a MAC and IP because it's got the MAC address and the IP address. So if we come on to leaf 1 and we do this command again, we can see that we have got two entries in here. We've got a local entry, which is 10.1.1.1, which is, this is its MAC address, and we can see its physical location within the device is down port channel 2, which we'd expect. and then we can see that 10.1.1.10.1.1.2, which is server 3 VLAN 10, is connected remotely to us, and we can see that that's its MAC address, and we can see the remote VTEP peer, and we can see that that address is the secondary address on the loopback rather than the primary address. If we looked a bit further to VPN, EVPN, and we specifically looked at this, we can see a lot of things on here, but if we were on leaf 1, so our route distinguisher is .3, so this is essentially the output we want to be looking at, because we can see that it's been imported from another route distinguisher. But if we look here, we can see everything about the route, so we can see that it's come from the route reflector. We can see that that was the originator, so we've got 1 from 5, 1 from 6, so 5 and 6 are leaves 3 and 4. So we can see that each has sent us the route. We can also see there is a site of origin on these routes because we're using vPC. So the site of origin will essentially kind of stamp that route to say that this is where I've come from, so that what can't happen is, for example, leaf 3 sends a route out to the spines and it ends up going back to leaf 4. Leaf 4 will see that it's got its own site of origin on that route, and it will say, no, I'm not going to accept that. It's a bit like having a duplicate autonomous system in the AS path. It's a kind of a BGP loop mechanism that's used. So pretty much that is the underlay and the overlay and the L2 VNI set up. What we can do is, if we disconnect these, we'll just check that VLAN 20 is working. So we'll jump on to server 4 VL20 and server 6 VL20. Check the IP address on this is 10.2.1.2, ping 10.2.1.2. We can see that's working as we would expect. And then if we looked back on the switch, if we did a show out expression cache for VLAN 20, we'll see that from the perspective of leaf 1, because those two servers were on remote nodes or remote leaves, these are both in as remote entries, and again we can see the remote VTEP address is the secondary address on that NVE loopback essentially. So that's good. We've got connectivity. The one thing we won't have at the minute is connectivity between server 1 and between VLAN 10 and VLAN 20, because at the minute all we've got is bridging set up. So inter VNI traffic is working. What we need to do to get the layer 3 traffic working is to create an L3 VNI and to start looking at Anycast gateways, and we'll do that in the next part.